Today's lesson, we will be continuing our study of solving equations. Today, we're going to be working with solving equations that have variables on both sides of the equal sign. For example, 6x minus 2 equals 3x plus 1 has variables on both sides. In general, you can follow these 5 steps for solving equations. You might copy these down on an index card, refer to it often. The first step is always to distribute if possible. The second, collect like terms. The third, collect variables on one side by adding or subtracting. Number 4, you'll undo any addition or subtraction. Number 5, you'll undo multiplication and division. Let's look at some examples. In our first example, we have 7n minus 2 equals 5n plus 6. This is a fairly simple equation. There is no distributing to do. We don't have to collect any like terms. But notice, here's our equal sign. We have an n on the left and an n on the right. We want to collect those variables on one side of the equal sign. We want to put them on the left. To do that, we will subtract 5n from both sides. Notice, we subtract 5n just as we would subtract the number 5. So on the left, we have minus 5n. We bring our equal sign straight down. On the right, we have minus 5n. 7n minus 5n is 2n because 7 minus 5 is 2. We still have the minus 2, and on the right, 5n minus 5n goes away. We have the number 6. Here we have a fairly simple equation to solve. To solve this for n, we will first add 2 to both sides, therefore undoing the subtraction. That gives us 2n equals 8. And finally, we will solve for n by dividing both sides by 2. 2n divided by 2, the 2's cancel. 8 divided by 2 is 4. Our answer is n equals 4. To check our equation, we put 4 in for the n in both places, on both sides of the equal sign. So we're putting it in this original equation. 7 times 4 is 28, minus 2 is 26. On the right-hand side, 5 times 4 is 20, plus 6 is 26, and it checks. Let's do another example. In this example, we have a lot more to do before we can get to the business of solving equations. Remember our steps from the very beginning. Step 1, distribute. As I look at this problem, I see, yes, there is something to distribute. We're going to take baby steps. Before we worry about distributing, we're going to rewrite the subtraction as addition. To do that, we make our minus 5 into plus negative 5. We're adding the opposite of 5. Now we have 4 minus 6a plus 4a equals negative 1 plus negative 5 times 7 minus 2a. All we do in this next step is distribute. That means we're going to multiply negative 5 times 7 and negative 5 times negative 2a. That's what we're doing right here. Negative 5 times 7 minus, because this is a minus sign, negative 5 times 2a. In the next baby step, we'll multiply. 4 minus 6a plus 4a equals negative 1 plus negative 5 times 7 is negative 35 minus negative 5 times 2a is negative 10a. I'm going to do 2 things at once in the next step. I'm going to combine like terms and simplify. On the left-hand side, notice you have negative 6a plus 4a. Remember to combine like terms, you add or subtract the coefficients. The coefficients are negative 6 and 4. Negative 6 and 4. Negative 6 plus 4 is negative 2a. On the right-hand side, our like terms are a negative 1 and negative 35. Negative 1 plus negative 35 is negative 36. Here, we're just going to write the minus and negative. When we subtract, we add the opposite. The opposite of negative 10a is positive 10a. So it becomes plus 10a. Now we still have variables on both sides. On the left-hand side, we have we have a negative 2a on the left-hand side. We have a positive 10a on the right-hand side. To collect our variables on one side, we will add 2a to each side. When we do so, negative 2a plus 2a is 0, so that goes away. We're left with 4 equals negative 36 plus 10a plus 2a is 12a. Now we have our variables on one side, and we have an equation to solve. To solve this two-step equation, we first add 36 to each side because we have a negative 36, so we want to add the opposite, which is a positive 36. On the left-hand side, we have 4 plus 36, which is 40. Negative 36 plus 36 goes away, and we still have a 12a. To finish this problem, we divide both sides by 12. When we reduce the fraction, 40 over 12, we're going to divide top and bottom by 4. 40 divided by 4 is 10. 12 divided by 4 is 3. Here's our answer. So what do we do in this problem? Step 1, we distribute it. After we distribute it, we combine like terms. After we combine like terms, we collected our variables. Again, you'll want to make an index card or put this in your notes or something. After our variables are on one side, we'll undo addition and subtraction. After we've done any addition and subtraction, we undo multiplication and addition. So the problem had a lot more steps, but if you take it one step at a time, you can do it. I'm going to introduce a new term here called identity. An identity, we'll use this a lot. An identity is an equation that is always true no matter what value is substituted for your variable. The solutions of an identity are all real numbers. There's another new word you won't see in your book, but it's the opposite of an identity, called a contradiction. A contradiction is any equation that is never true. These equations have no solutions. Let's do an example that shows an identity. Look at this equation right here. And again, you should be taking notes to show me that you have watched this video. We have the equation 10x minus 5x plus 1 equals 7x plus 11 minus 12x. That's what we're starting. Step 1, there's no distributing to do, so we're going to combine like terms. To combine like terms, we look for numbers that are alike or variables that are alike. 10 plus 1, these are constants and we can add them. 10 plus 1 is 11. That's where the 11 came from. Minus 5x. There's no other x's on the left-hand side of the equal sign. On the right-hand side of the equal sign, we have 7x and a negative 12x. Yes, this negative sign stays attached to the 12x. Subtraction and negative numbers work the same. So to combine these like terms, we're going to combine 7 minus 12, which is negative 5. So our coefficient for the x term is negative 5. 7x minus 12x is negative 5x. We also have plus 11 on the right-hand side. We bring that 11 down. Our next step is to collect the variables on one side. We collect them on one side. Well, here's a minus 5x. There's a minus 5x. Well, I'm going to add 5x to each side. But when that happens, I have no variables left. And I'm left with the statement 11 equals 11. 11 equals 11 is a true statement. It's always true. 11 will always equal 11. So if after you collect your variables by adding or subtracting, you get one number equals the same number, it's called an identity. When you have an ending statement like this, where the left and right are exactly the same, your solution is all real numbers. Now let's look at a contradiction. In a contradiction, you, after solving your equation, will find a false statement. So looking at this original equation, 12x minus 3 plus x equals 5x minus 4 plus 8x. There's no distributing to do, so we're going to combine like terms. 12x plus x, remember, if you don't see a number in front of your variable, put a 1. 12 plus 1 is 13, so 12x plus 1x is 13x. On the right-hand side, we have a 5x and an 8x. 5x plus 8x is 13x as well. So we're going to put a 13x there. There's a 13x on both sides. We're going to collect our variables on one side by subtracting 13x. We no longer have any x terms. We're left with the statement -3 equals -4. That's a false statement. -3 cannot equal -4. It will never equal -4. The statement is never true. There is no value of x that will make the equation true. So we say there are no solutions. Now we're ready to practice. Come to class tomorrow with your notes and we will practice. Thank you.